Okay, so we're studying periodic functions, and periodic functions can be used to model things that rotate. So things, wheels, in this case we're going to be looking at the pedal of a bicycle, carousels, merry-go-rounds, Ferris wheels, objects in space. Sound waves are characterized as periodic functions. They're part of periodic motion that you study in science. But here we've got a problem. It says a cyclist pedals a bike at a rate of 1 revolution per second. Now, this picture that I've got here comes from the very beginning of the chapter, at the very top. And in this, what we're looking at here, it was showing the revolution of a pedal in 2 seconds. Now, we're talking about a cyclist that's going to be pedaling this bike at 1 second. So we're going to change this 2 seconds to 1. And this pedal is moving counterclockwise. It's moving counterclockwise. And as it gets 1/4 of the way around, and we're going to change that to 0.25, 1/4 of the way around, the pedal is at 11 inches from the ground. And when it gets down here to the bottom, which in our example, when we got 1 revolution per second, this would be at 0.5. It's 4 inches from the ground. And then at 3/4, or 0.75 in the case of 1 revolution per second, it's back to 11 inches off the ground. And at the end of 1 second, it's back up here, which is 18 inches off the ground. The pedal is now 18 inches off the ground. And this cyclist is pedaling this bike where the pedals are rotating at a period of 1 second. So it says, make a table showing the height of the bicycle pedal at times of 0, 0.5, 1 second, 1.5 seconds, 2 seconds, 2.5 seconds, 3 seconds. So let's see. Let's take this diagram and figure that out. Well, we start here at 0. That's our starting point. Well, it's at 18 inches. And if we had this on a graph, which we will in a moment, the x-axis is time, and the y-axis is the height of the pedal. And we'll see that in a moment. All right, at a 1/2 second, where are we going to be at a 1/2 second? Well, we're going to be down at the bottom. It's going to be 4 inches. The height of the pedal is going to be 4 inches. We get back up here to 1. It's going to be 18. We come back down here 1.5 seconds. It's going to be back to 4. We make a second revolution around, and we're going to be back to 18. There's 18 inches right there at that height. 2.5. Well, we're back down here at the bottom at 4. And at 3, we're back up here to the top. And so the pedal is now going to be 18 inches from the ground. Now, the second part of this example, which was example 3, on page 831, it says identify the period and graph the function. Let's move over here to the next slide, and I have plotted some points on a graph to model our table. And if you look down here, we've got our x-axis, and again, this is a function of time. And it's 1/2 second, 1 second, 1.5, 2, 2.5, 3 seconds. So we got the 3 seconds here. And the y-axis here is the height of the pedal. The height of the pedal. And so when x was 0, or at 0 time, we had the pedal was 18 inches off the ground. At a 1/2 second, it's down here at 4. So this point is relative to 4. This up here is at 18. In 1 second, we're back up here to 18. 1.5 seconds, we're at 4. 2 seconds, we're at 18 again. 2.5 at 4. And at 3 seconds, we're back up to 18. Now, if we were to graph this or connect these points, and you'll probably have to forgive my shaky hand here. I'm coming down here like I'm going to come down here like this and then back up. Whoop, got to erase that. Coming down here like this, up here like this, down here like this, up here like this, down here like this, and back up like this. And we're being asked for the period. Well, the period starts right here. We cycle down and we cycle back up right here. And so the period is 1. Takes 1 second for a complete cycle. Now, when we get, and we will shortly, get into looking at sine and cosine functions, those are periodic functions. They don't take quite as big a swing as this ordinarily without some pretty big transformation in the amplitude. But I will save that part of it for a little bit later. So anyway, there we go. We have graphed a periodic function based on the height of a pedal off the ground when a cyclist is pedaling the bike at 1 revolution per second.